Hello, this is the voice of BitBirds. This video is going to be an informal walkthrough of how this BitBird generation Python script functions. I will be jumping on and off the screen because on a couple previous takes I've opened up a file tree that has my full name in it or something like that. So bear with me on that one. Before I dig in, I did want to mention that if you're just getting into this and you're not really that familiar with programming, I'll kind of set the expectation that setting up the dependencies could be a bit of a tricky process for you, but if you're persistent, I believe that you can do it. Often in technology, installing something like pip, which is a Python installation mechanism, is something that the developer doesn't even really think about because it's been on their computer for a long time and they use it all the time. So setting that up for someone that's coming into it new can be a bit of a tricky sticking point in my experience. If you're having issues, please reach out to the community. We would certainly not want to deny you the opportunity to struggle, but at the same time, we don't want you to get stuck and kind of give up. So reach out to the community on Twitter or Discord, and we'll see if we can get you sorted. So without further ado, this is the asset that I will be sharing. I'll share a link right to this GitHub repository on Twitter and on Discord. If you're familiar with Git, you can clone this repository. If you're not, often it's easiest to just go right to this section and say, I want to download this repository as a zip file. Actually, that is somewhere that, in my experience, it has popped up my name. So I'm going to pull this off screen real quick and click that download zip button. Cool, so I've downloaded that right to my desktop. I can drag the file over here. It is generate-bitbirds-main.zip. Depending on your computer, you can extract that zip file in different ways. It might be right-click, extract, or something like that. But what I do on my Mac is just double-click it, and that leaves us with a folder here of generate-bitbirds-main. So if I jump into that, these are the assets that make up this repository, basically. So we don't need this necessarily anymore. This is where we are working from here on out. The BitBird generation script is how the images are actually generated. This bird images folder is where they will be generated to. And I've got a placeholder text file in here just so that GitHub does include that file. If I were to just click this, it would open in my code editor, Visual Studio. There's some other good ones like Sublime Text and Brackets and Atom and just many of them. But I can go ahead and open this and it will pop us into VS Code. Now, you can run this in a number of ways. You could run it from the command line if you're familiar with that. VS Code has a pretty convenient little execute button in the top right here. So this little play button up here, green arrow, is going to let us run that. When I do go to run that, it will, again, pop up a terminal with my name in it. So I will pull that off screen to do that. Right now, I'll pull open this bird images folder, and we'll be able to actually see the images generate in there as I hit execute. And so I've just done that. I'll pull this down, and this is super zoomed, but we'll go through how this script is functioning. Python often has you import different libraries, so that's what we're starting with. We're importing, this one is the Python imaging library, and specifically a fork of the original Python image library called Pillow that my understanding is it works better with Python 3. And so this is basically just telling the code, we can now use the resources of this PIL functionality. Same sort of thing with NumPy here. I like to call it NumPy personally, but that's probably wrong. It gives us the ability to work with arrays. Importing OS gives us the ability to interact with some things about the operating system itself. So for example, we are going to use that to generate a path to where we're going to create these files, because it'll do that dynamically. In my original version of this, it just had a static path through users / my name / whatever to get to this bird _ images folder, but we need to do that dynamically because that path would not be the same on your computer. This random library allows us to generate pseudo-random numbers. And I go into a bit more about what that means in the README, but effectively what it is it'll generate a deterministic random number. So from the same starting seed, we'll see a bit later, it'll always generate the same first random number and then the same second random number and that sort of stuff. So it's not truly random in a mathematical or a security sense, but it does give us enough variation that we can kind of generate these randomized birds. Last bit here is it's just setting these couple variables the directory name so that it can use it later for the sort of the path to where those files will be created, and then the dimensions of the image, which we'll use later at 480 by 480 pixels. Once we get to this point, this is basically a loop. It is going to loop through this functionality for every single bird, and it will do it as we've defined here 50 times. It will start with time number 0. It will run to time number 49. I don't believe it'll run to number 50, but we can actually probably check that on the birds itself. Yeah, so it runs to 49 there. It does include, seems to include the first number, doesn't include the second number. That's kind of devil's in the details sort of stuff. The first thing that we do in this loop that's generating each bird is kind of define a starting seed number. So in this case, I used the last ETH block that happened before I generated all of these images. And each time it loops through, it will add the iteration number to this. So basically, for the first time, it'll use it as 11981207. The next time, it'll do that plus 1. Then the time after that, that plus 2, etc. So each time, it's kind of starting each bird with a different seed number just by kind of using this. These random integer mechanisms are what are actually generating those pseudo-random numbers. So I'll actually give a 3-second overview of what's happening here, and then we'll jump down a little bit and we'll come back up to sort of this level. This is where we're generating all of the colors and all of the different traits of the birds. So we're generating the head color, the throat color, the color of the eye whites in crazy birds, crazy eye birds, the beak color, that sort of stuff. I'll pause on how specifically it's doing that to jump down very briefly. This is the image itself. So each one of these is itself a pixel. So this is a 24 by 24 pixel image. Basically, it has 24 arrays of pixels. So each array is a list. It's got kind of one big array here with a bunch of arrays in it. So each one of these is a line. And then each of these is a pixel within that line. So you can actually see as I'm highlighting this, you can kind of see where the variables are. These BG variables are background, the OL variables are outline, HD variables are head color, TH is throat color, beak color, etc. So this kind of gives you a picture of how this image itself is being generated. It's happening pixel by pixel with each of these variables. And actually, if we look over here to the right, we can see that in each of these different 4 blobs, you can kind of see the outline of the bird itself. And if you zoom way out on the code, just based on those slight differences in the variables, you can see those. I did choose 2-letter variables for all of these, just so that it would stay in nice organized rows and lines. And that makes it a lot easier to work with and to look at. So we've got one for woodpecker, we've got one for jay, got one for eagle, we've got one for cockatoo, and so we can see that the cockatoo's outline has these kind of crazy other lines and that sort of stuff. So with that in mind, that's the context I wanted to share as we go into how each of these different characteristics are being generated. The head color is using this random integer mechanism to generate something between 1 and 255 for each of the RGB values, so that's red, green, blue values in a color. So this will basically say something like, here's a static RGB value, for example. So 240, 248, and 255. That's a very light color. The sort of ends of the spectrum here would be 000 is totally black, 255, 255, 255 is totally white. And then you've got a range of stuff in between there. So you could say, I want to do, I don't know if it's percentage or basically units of red or units of blue in this color. So it's kind of like when you go to Home Depot and they're mixing you up some paint. So the first bit here is generating that RGB value for the head by generating 3 random numbers between 1 and 255. Same thing with the throat color. So in theory, these could all be random. In the README on the GitHub repository, I've put some more notes, and I'd be eager to discuss these if folks may spy some patterns or know more. I do think the way I'm using these seeds to basically say I'm going to generate from this number a next random number, and that next random number is going to be the seed for these. I'll generate a new random number. So they're kind of, these random numbers are chaining off of each other. And I think with some of these logical layers, it's causing certain behavior where certain attributes seem to not be able to pair up with other attributes. For example, I don't think I certainly haven't seen any, and it seems to me that this script, the way the logic chains together and decides on beak color and then decides on which bird, it seems to never be able to generate a red-beaked woodpecker. Another example, and actually the one where I originally realized that there may be some strange behavior going on, it was about halfway through the minting, so we were already in it to win it. I realized that all of the cockatoos had the same blue crest. So as I mentioned in the README, I've actually gone through and for cockatoos number 2, 3, and 4, I've done a separate run of cockatoos and swapped those blue crested ones in with some others just so that there's a little bit more variability to those. It wouldn't be fun to have all 4 of the unique special cockatoos as pretty similar birds with the blue crest. But other than that, this exact script is precisely the birds that are minted as NFTs. And those cockatoos, I will mention, those were only put in the place that the random order did actually already generate a cockatoo. I just changed a little bit of which ones were going into those 4 slots of 1,500. So what we saw in the first bit is it's generating sort of those color variables randomly. This is where we get into a bit of a different angle, and it's using a random number to basically define some sort of logical statement. So here we're saying we want to set D equal to a random integer between 0 and 1,000. That could be 683, it could be 14, yada yada. And so basically here it's just saying, okay, in this sort of chain of random numbers, when we get to D, if D is less, or if D is 47 or less, or if D is specifically greater than in this highlighted one 47, then it's going to be normalized. So they'll have this almost white eye background and black pupils, or else, so this else would hit if it's 47 or less, so a 4.7% probability. If you're looking at 47 out of 1,000, then it'll have crazy eyes. So in that case, we're generating the eye white color, sort of the background of the eyes, in the same way we're generating this top bit for the throat color and the head color, and then the eye pupil is sort of a very reddish, sort of crazy looking thing. So that's how we kind of make the logical decision to say this bird should have crazy eyes or should not have crazy eyes. We take that same sort of thing even a little bit further into the beak color. So here we'll say we want to set the beak color. We want to do a variable called f. Again, we've sort of, from the previous sections, defined a new seed. So it'll kind of generate a random new number for each of these sections. And we're basically saying, okay, for f, we want to make that a random integer, again, between 0 and 1,000. So again, it could be 983, it could be 12, whatever. And then it's going to evaluate that. And it says if f is greater than 500, then it's going to be gray beak. If it's between 500 and 47, pretty much with some equals and not equals in those, then it'll be a gold beak. So gold beaks and gray beaks are most of them. That's basically from anything 48 to 1,000 is going to be a gold beak or a gray beak. The red beaks show up if it's between 47 and 8, the way this, greater than or equal to, and this is just greater than. So 7 is not included in this particular calculation. 47 is included in this calculation, just for folks that may not recall that or may not know the syntax of that in Python. But yeah, basically this is saying it'll be a red beak if the number generated is between 8 and 47. And then other than that, that's basically saying everything else it's already spoken for. If the random number is 7 or less, that's how you get a black beak. So that is slightly less than a 1% probability of a black beak on any given bird. Background color and the outline color is going to be the same every time. So that's just kind of a gray and a black outline. And then we get to the section where we're defining all of these birds. We've already taken a look at that. Perhaps it will resonate a bit more now that we have some context on how each of these variables are being set. So, we've got the J outline variables. We've got that randomly generated head color, randomly generated throat color, sort of selected beak color that comes from a handful of pre-configured options. We've got the eye pupil in those 2 pixels, and then we've got the eye white in those 6 pixels. And so unless it's a crazy eye bird, that will always be the same sort of lightish gray, but not pure white. So we've got the eagle, we've got the cockatoo, and here's where we actually decide which bird to use. Again, we've got a seed number and we're generating a random, and then we're going to make a decision based on that. We're basically saying, okay, If this random number, the last in our random number chain, is 251 or greater, since this one doesn't include 250, then it will be a basic bird. So roughly 75% chance, or maybe exactly 75% chance that it will be a basic bird. Or else, if it's between 100 and 250, then it'll be a J. So that's probably a 15% chance, of course, because 150 out of 1,000, 15% chance it'll be a J. Between 40 and 100, that'll be a woodpecker, so that's about a 6% chance. Between 5 and 40, that will be an eagle, with 5 not being included. So basically, if the number is 6 to 40, that will be an eagle. If the number then doesn't hit any of those rules, that means the number is 5 or less, and that is how we get a cockatoo. So from here, we're near the bottom of the loop. This is basically just saying we want to turn this into some data that is usable. I couldn't even say exactly why numpy is doing this or numpy is doing this, but it is. So I just go with it. This is using the Python image library, or Pillow, to create the image from this new array of pixels. Here's where we're actually generating the file name that will be used for this. So it's basically looking now for a folder in the same folder as this. We've got the dir name, that would be like users / name / desktop / projects / whatever. So that's going to find wherever we are dynamically, wherever this is being run, put that at the beginning of the URL, I guess, or kind of the file path. It'll then say, okay, and we're going to add /bird images. So this is now looking for the bird images folder, and it's looking for the bird number. So we saw, for example, that each of these is, number 9, number 10, number 11. You may recall that X variable was from way up at the top. That was like the iteration number. And then we're just ending it out with .png, which is the file name. And then this saves that file. At that point, we have created one single bird, and it jumps right back to the top. And it'll say, okay, now that we've created bird number 1, we are now on... So it'll start with 0, then 1, then 2, yada, yada. If we just created bird number 3, it'll say, okay, now we're on bird number 4. X is 4. We're going to say this is 11981207 plus 4, so 1211 as kind of the starting seed, and then it'll generate all those random mechanisms from there. So with that, I hope that was valuable. I would say if you want to explore and change this, a very easy way to test it is to start this with a different seed. If you were to say, hey, I want the seed to be 15 instead of this ether block number, that'll generate a whole different set of birds. If you wanted to mess with the number of birds generated, you could set this. How many loops basically is what this line is saying. It's saying as long as X is between 0 and 49, we'll keep doing this loop. And once we get to 50, we're done. But if you wanted to say, I want to make this 200 birds or something like that, you could absolutely do that, and it'll generate up to bird 199. Another area, if you're kind of looking to more get into the actual generative art layer, is to start messing with these. I could say, I want to make the outline of this, I want to make these background pixels be outline pixels or head color pixels or something like that. So this is kind of a very manual way to create an image pixel by pixel, but fortunately the program, once you've created the sort of template, can generate the images for you very quickly. You can kind of modify all of this. You could, if you really wanted to mess around with a bunch more pixels, you could do more than 24 by 24. You could do all sorts of different stuff. You can even add your own little variables in. If you wanted to say, there's like an eyeglasses variable or something like that. You could create your own variable. You could create some logic on how it's set. And then you're basically, would do something like if this random number that we've picked is, if we're given it a 50-50 chance, if it's greater than 500, then we want to set the eyeglass equal to a black or a brown color. That variable will then show as an eyeglass. Or else, maybe we just say, okay, we want to, if there's no eyeglasses, then we just want to set the eyeglasses equal to what would be in that position otherwise, like the head color or something like that. So I hope this was valuable. As I mentioned, This is an exciting area. It's really been a joy to explore. Please reach out to the community if you're really banging your head off of something. In my day job, I'm not a professional coder, but I do work with technology quite a bit. And the rule of thumb is usually, if you've spent more than half an hour on one particular error message that you feel like should be solvable, that's a pretty good threshold to reach out and raise your hand. And yeah, if you ask good questions, I'm sure the community and I myself will be very eager to help unblock you. So a good question will basically say, like, here's what I have, here's what I'm trying, here's what I have tried, here is what I expect to be happening, but instead I'm getting, this XYZ error message. The more detail you can provide, the more useful. What is not necessarily a good question is just kind of saying, like, I need help with this or something like that. That'll not get you too far in the rough and tumble world of the internet. I hope this will inspire someone. I hope it'll have someone or multiple people expand their skill sets. I hope you come to explore this and enjoy it and learn some new things, and maybe in some small way or large way can better your life from the experience of exploring this and learning from it. And I sincerely appreciate everyone's engagement with the BitBirds project. Thanks for watching.